we want to look at an inverting op-amp configuration and how the bandwidth of the op-amp affects the bandwidth with feedback. So we are going to start with our inverting op-amp configuration, which is similar to what you did in 240. So here is my R1 and this is my V in, and we ground our positive terminal, and this is my V out. So similar to what we did before, we're going to do a V1 right there, and we do node voltage, so V1 minus V in over R1 plus V1 minus V out over RF is equal to 0. And then we can do, might as well simplify that down. It's equal to V in 1 over R1 plus the V out times 1 over RF. Okay, and then we're going to use the amplifier gain, and so we see that minus A times V1 is equal to the V out, because the V1 is connected to the negative terminal, which means that V1 is minus V out over A. So then we're going to take that V1 and plug it into our previous equation, and so we have minus V out over A times 1 over R1 plus 1 over RF, which is equal to all the stuff we have up above, plus the V out times 1 over RF. Okay, so we can simplify that and add the two V outs together. And so then we have V out times 1 over RF plus 1 over A times 1 over R1 plus 1 over RF, which again is equal to the V in times 1 over R1. And this is negative over here. Okay, so then going through this, we're trying to get our gain. So V out over V1 is equal to minus, well, let's go ahead and multiply through by that R1 first, just to get the V in by itself. So we have V out times R1 over RF plus 1 over A times 1 plus R1 over RF equals minus V in. And so then we get V out over V in is equal to R1 over RF plus 1 over A. Might as well combine these two together. RF plus R1 over RF inverted. Okay, so now we have this, but we're going to have to invert this, so we might as well combine these two pieces together to get a common denominator. And so then we have A times R1 plus RF plus R1 all over A RF minus 1, which then we can flip it over, A times RF over A R1 plus RF plus R1. Okay, so there's our gain. And then what we want to be able to do is we're going to come in here and say that our gain is equal to some open loop gain divided by 1 plus J F over F naught. Okay, so then again, like we did before, we're going to take this and plug it in here, and take this and plug it in there. Okay, so then what we get is we get A0 over 1 plus JF over F naught times RF all over A naught over 1 plus JF over F naught times R1 plus RF plus R1. Okay, and then like we did before, we're going to multiply through by the 1 plus J. And it looks like we lost our minus sign all the way along here. So we can come back and put that in. Okay, so we're going to multiply the top and bottom by the 1 plus JF over F naught. So we have A0RF over A0R1 plus RF plus R1 plus JF over F naught times R1 plus RF. Okay, so then like we did before, we want to get the bottom in terms of a 1 plus JF over F. So this is going to be, well, before we do that, these two are going to be negligible because the A times R1, A naught times R1 is much, much bigger than RF and the R1. So then we have minus A0RF all over A0R1 times 1 plus JF over F naught A naught times R1 plus RF over R1. And then we see that these two cancel off, and we are left with minus RF over R1 times 1 over 1 plus J F over F1, where F1 is equal to F0A0 divided by R1 plus RF over R1, which is equal to our gain bandwidth divided by 1 plus our single stage inverting amplifier gain, magnitude, if we worry about the sign. Okay, so what we see here is if we compared this before, let's compare our inverting and non-inverting. So with our inverting, our F1 was equal to the gain bandwidth divided by our single stage gain, times 1 plus. And for the non-inverting, we had F1 is equal to the gain bandwidth divided by the single stage gain. So you see they're pretty close. If the gain is much, much greater than 1, then they're basically equal. Otherwise, the frequency of the non-inverting is a little bit higher than the inverting stage. And if we want to kind of finish this up, this is equal to 1 plus RF over R1, and this one is minus RF over R1. And that's how we have, and then we're all done with the inverting op-amp configuration.